Please welcome Ian Hellstrom from D2IQ.
When enterprises wish to promote machine learning prototypes to production, there is only one man who can solve the Riddler's precarious prototype to production puzzles: Batman. Unfortunately, it's been a while since you came across his resume for a data scientist position. What is more, the simple fact is Batman is busy. He's washing his tights, clipping his toenails, chasing the Riddler down a manhole, or filling up the Batmobile at the petrol station. He's also only one man, one fictional man. He's not coming to save anyone. My name is Ian Hellstrom, and I am the product manager for Captain, D2IQ's cloud-native enterprise machine learning platform. I've been battling data and machine learning villains for the better part of a decade in companies such as D2IQ, Spotify, Bosch, and Ciovo, both as an engineer and product manager. In this talk, I will share insights on the traps I have seen companies fall into when it comes to getting value out of machine learning, and of course, how to avoid them. We shall explore how companies can succeed at machine learning without a Batphone. Think back to when you were 6 years old and what you wanted to be. Take a moment. Few, if any, wanted to be plumbers, even if you spent most of your childhood saving Princess Peach from Bowser's doomed kidnapping attempts. And if that was the reason you went into plumbing, your first day on the job may have been a huge disappointment when jumping into sewage pipes yielded few gold coins. Data and machine learning infrastructure are the plumbing for your organization. You don't really think about it, but you want it to work without fail. And if it does fail, all hell breaks loose. Ideally, machine learning initiatives work without anyone having to rush over to the Batphone. The problem with the plumbing analogy is that it's apt. Data is often treated as a waste product to be refined by data scientists. Many companies will claim they see data as an asset and machine learning as a key enabler of future growth, but the reality for people knee-deep in raw data is markedly different. So, let's don our cape and cowl, squeeze into the tights, and find answers in technology, talent, culture, and the eternal struggle between expectation and reality. To the Batmobile. Perhaps the first thing to clarify is that I'm talking about operationalization of machine learning models. There are two reasons why I'm restricting myself to talking about promoting models to production. One, that is where you see any returns on investments. Two, that's where the majority of initiatives fail. When I say majority, what exactly do I mean? 87% according to VentureBeat and 85% according to Gartner. That's almost 9 out of 10 initiatives that fail. This matches my own experience, and it is in line with data transformation projects in general. Model deployment issues are a barrier to adoption to more than a quarter of companies. Note that only 1 in 10 companies report significant payoffs from machine learning. So what's stopping people? Gotham. When it comes to the operationalization of machine learning, there are 6 traps that companies can learn to spot and avoid. Let's take a closer look at each of these. Every time the Riddler is caught by the dynamic duo and put back in prison, he somehow manages to escape to terrorize Gotham City, again and again. While it offers a great prompt to another episode, it is a common enough pattern in business worth highlighting, dealing with symptoms instead of the cause. Issues related to data fall squarely into that category, especially when issues are dealt with as one-offs. Data is by far the most important and most overlooked aspect of machine learning. Of course, everyone in the executive suite claims their data is an asset rather than a byproduct of doing business, but the reality is quite different. Talk is dirt cheap. Am I exaggerating? Not really. Issues with data quality cost businesses up to a quarter of their revenue. While infrastructure engineers or administrators are typically responsible for the systems, they are rarely responsible for the contents of said systems, and rightly so. Unless people who have a stake in the quality of the contents are made responsible for the data and have the authority as well as technology to expose and fix issues, data will always be messy. Such data stewards or guardians ought to be core to any data organization, although there is a risk in making individuals responsible for cleaning up everyone else's mess. Frustration is the data governance sinkhole. Being left too long on have-to work is a guarantee of eventual boredom, as Michael Lopp, author of Managing Humans, wrote in the chapter entitled Bored People Quit. And of course, bored people quit. Data quality is a multifaceted concept, and it must be assessed along several dimensions. Is the dataset available and accessible to users who are authorized to access it? Is the dataset available on time? Is the dataset complete? Are all fields within acceptable ranges, or do they take on predefined values? Are the correct data types used with the right number of significant digits? Are all fields and records defined, understood, measured, and stored consistently? Is the dataset accurate, reliable, or at least fit for purpose? And finally, is the dataset trustworthy? And that is not all. You can also think about confidentiality, compliance, understandability, and recoverability in case of human error or a disaster. Remember, data quality is everyone's problem. You bought the tech, you brought in the talent, now you just lean back and wait for the magic to happen. You wait, and wait, until you finally reach for the Batphone. Only no one answers. Batman is busy being fictional. The expectation when starting small, as the common advice goes, is that prototypes will scale up, or that at least productionization is somebody else's problem. Since DevOps has been around for a while, surely that's a solved problem. This is the hallmark of the operationalization as an afterthought trap, the misguided belief that a Jupyter notebook on a data scientist laptop is a solid enough foundation for a production-grade solution. As Google already noted in 2014, a production machine learning system consists 95% of glue code. Only 5% of any production machine learning system consists of the model code itself. The model is but a small cog in a much larger machine. There are several aspects of this trap, and we shall look at each of them separately. Let's first take a look at what you need to deploy machine learning models to production reliably, repeatedly, and automatically. Remember, that's when you can see sustained positive returns on your AI investments. By doing so, we'll see that machine learning in production is different from DevOps. In fact, they are as different from each other as two nations. The inhabitants of Data Science Island are somewhat isolated. They rely almost entirely on notebooks, Jupyter, Zeppelin, or otherwise. Python is their primary language, but you can also hear data scientists speak in R and to a lesser degree Julia. Even if they speak Python, they usually favor different dialects, TensorFlow or PyTorch for deep learning and scikit-learn for traditional machine learning. But there are many more local variations audible on the island. The way data scientists ship their products is mostly through virtual environments. While they may be familiar with containers to run notebooks, most still rely on virtual environments. Left to their own devices, data scientists are a happy bunch, as long as the data quality does not ruin their day-to-day life. The only problem is, the models they have built don't generate a lot of value, if any at all. To see the benefits of their labor in production, they have to cross the ocean to Opsland, a voyage fraught with danger. Of course, it starts off easy. Package your work in a container, it reads in the travel guide. Boil some copy pasta and Bob's your uncle. No sweat. But problems appear quite quickly. Some turn back to the safety of Data Science Island, while others have packed their shark repellent spray in their imaginary utility belts. They can safely swim to the shores of Opsland, only to be greeted by a bunch of weird natives. It's filled with engineers. To these engineers, everything is a container and everything needs to be properly tested. Looks okay does not cut the mustard here. They also ship nothing without a fully automated CI/CD facility. The DevOps engineers on the shore talk about deploying individual artifacts, but that's not suitable for machine learning. In machine learning, the entire workflow of multiple steps with logic to move from one to the next is deployed, not just the container with model training, the data transformation, or the fully tuned model. It's possible to do it that way, but ideally the workflow orchestrator can pick up where it left off in case of failure. In machine learning, we deploy the entire factory, not just the final product. The stray data scientists cannot find a single notebook anywhere, so they move on. After an arduous climb, they reach the MLOps mountains. The MLOps communities have gone native and they have adopted DevOps traditions. At least the machine learning engineers here know about the challenges of machine learning and they know how to deploy an entire workflow. But they rely on DevOps-like tooling and terminology. None of it looks familiar to the data scientists. They keep calm and carry on. Beyond the mountains lies a valley inhabited by the data ops people. These data engineers know about data pipelines, orchestration, schema management, data versioning, and so on. Feature stores can be found in select boutiques on the foot of the mountains. After spending some time in Opsland, the data scientists noticed that most engineers here speak Python, but also Scala or Go. And the way they speak Python over here is quite different from what they are used to. It's also formal with unit, integration, scalability, and resilience testing, but notebooks are nowhere to be found. The reason why all Opslanders rely heavily on DevOps tools and terminology is that a lot can be reused. CI/CD, configuration and resource management, automation, observability, and so on. To deploy a machine learning model to production, everyone's expertise on this map is needed. The model itself and all relevant features, the ability to automatically test and deploy software, or DevOps, the ability to automatically test and deploy entire machine learning pipelines with orchestration, that is MLOps, and of course the ability to automatically check, version and annotate datasets, deploy entire data pipelines with orchestration again, and manage schemas. In short, DataOps. It is why I advocate for the combination of DataOps and MLOps, DMLOps for short. Because data is the fuel for the machine learning rocket. Without the fuel, the rocket is just an expensive monument on the ground. And without care, it can easily blow up on the launch pad or in flight. The problem, therefore, is not so much that data scientists cannot operationalize models, it's that companies hire data scientists with the expectation that it's a trivial matter, whereas in reality, the operationalization is anything but. So, how do you go forward? Well, you have three options. First, do what has historically been done. Have a hard split between science and engineering with handovers. This is more or less what the bat map showed. I'll talk more about that in the management trap, so you have not heard the last word on that. Mind you, it's not what I recommend. Second, train engineers, especially data or machine learning engineers, to build models. This is an often overlooked option, and I'll talk about that in a little while too. Finally, give data scientists the tools to deploy production-grade pipelines for training, tuning, and deploying. That means making the tools data science friendly as much as possible. This is what engineers are great at, abstracting the details away. It amounts to building a bridge across the sea between Data Science Island and Opsland. But even with data governance and data science friendly tools for operations, companies are still liable to three stumbling blocks within the operationalization as an afterthought trap. First, make sure you measure before and after in terms of business metrics, not model performance metrics. Model performance metrics rarely map one-to-one to KPIs the business cares about. Tweaks to a model that aim to eke out the last drop of performance may go to waste outside of the lab. Unless what happens in the lab also applies to real life, it's a waste of time. Second, even if you do measure the before and after, it may be that your intended operationalization is not practical. For example, if you have a fixed time window for payment verification and your infrastructure cannot handle that latency, tough luck. Likewise, if you want to grab faulty intermediate goods off an assembly line, but quality control does not want a robot arm moving quickly over delicate components, tough luck again. But that could have been avoided if making the model operational was part of the prototype or at least part of the problem definition. Thinking a problem through is an easy step to skip when you're itching to build a fancy model. It sounds like common sense, but all too often common sense is a superpower. Blind adoption is the final obstacle in operationalization as an afterthought. A lot of technology available is built by tech companies for tech companies or similar. If you're shown the wrong ad, no harm done. If a spam email slips by, hit mark as spam. If an oddball product is recommended, just keep on scrolling. Out of the box, many standard evaluation tools and techniques look at the average performance. Where that is not okay is in healthcare, medicine, finance, and manufacturing, where safety and compliance are paramount. In these cases, the worst case performance of a machine learning model is often more important than the average performance. After all, you want the airbag in your car or the defibrillator in the hospital to function properly and not more or less. So, don't copy thinking everything has already been figured out. Adapt evaluation criteria to the business context. Batman may be able to spring any trap thanks to his unique utility belt, but that's only because the laws of physics do not apply to fiction. It's a common misconception that a new piece of technology will change everything for the better, but what it really does is add more work without a huge payoff. If companies believe ML to be the crystal ball for their business, they may discover the ball is made of glass and it's an ordinary paperweight, functional but not imbued with supernatural properties. There is no magic technology that solves all your problems. We can trace a lot of this irrationality around technology to various cognitive biases. Newcomers to production machine learning underestimate the complexity, whereas experts from related fields such as DevOps overestimate the difficulty of using and adapting existing technology to suit ML's needs. This is the essence of the Dunning-Kruger effect applied to machine learning infrastructure. Overconfidence in enterprise software is not unheard of, and machine learning is no exception. More than half identify as mature adopters of ML technologies. How hard can it really be? This is where we encounter present bias. Unfortunately, most of the cost is upfront with infrastructure, integration, customization, and of course training. The spoils of machine learning are mostly delayed. But this does not square with the "I want it all and I want it now" mantra that is almost implicit in the adoption of any new technology. Let's not forget that many prefer to DIY a platform from scratch without really understanding what they're getting themselves into. It took many engineers inside tech companies many years and many iterations to arrive at the platforms that so many others seek to emulate without really looking at their own needs. Their DIY platforms are often held together by duct tape and prayers, but mostly the latter. The IKEA effect is what makes people value what they build or assemble themselves more, regardless of the result. Technology is obviously an essential component of machine learning, but there is more to machine learning than technology. Talent is crucial too, but not the way you probably think about it. No Batman is an island, full stack is a fantasy, it's all about teamwork. Unfortunately, there are companies out there who look for bat persons who can do everything. I've worked with plenty of great people, but not a single one was capable of doing it all. What you need is a cross-functional team. Data engineers, data scientists, machine learning engineers, back-end and front-end engineers if applicable, and a product manager. What happens in practice is that data scientists interact with stakeholders through various projects, in which they also pose as the project managers with little or no training. The project team usually consists of the data scientist, a business person or two, and if you're lucky, a fraction of a data engineer. The problem is that the data engineer has no intention to build ad hoc pipelines all the time. Engineers release properly designed and well-tested code, not quick hacks. But that's too slow for the data scientist, so most code is built to get the job done quickly, but with little consideration for maintenance, production usage, or costs. After all, it's a one-off project, not a product. And that's exactly the problem. A project has an end, at which point it's considered done. The result is either handed off to engineers to make it production worthy and scalable, which we have already seen as the operationalization as an afterthought trap, or it remains a soon-to-be out-of-date notebook on GitHub linked from a slide deck where it generates absolutely no value. If you see AI as a collection of projects, you'll never think of it as anything but one-offs that fail to live up to expectations, as ownership is hazy and operationalization an afterthought. Okay, so you cannot hire Batman to do everything. What about training people already in your employ? Analytics is often where people look first. A lot of people mistake machine learning for advanced analytics, which it is not. Yes, SQL and data visualization are important to both, but that's where the similarities end. Going from a Tableau dashboard and a bit of SQL to a production machine learning system is more than a few Coursera courses away. It's possible to train people, but it's easier to make engineers learn modeling than it is to teach analysts operations as well as machine learning. It's much easier to turn a great data or machine learning engineer into someone who can build models as well as productionize them than it is to turn data scientists into people who care about operations, especially without proper abstractions. That is, without the bridge between data science island and ops land. The flip side of these unrealistic expectations towards employees is the grand expectations of data scientists themselves. However unreasonable these expectations from data scientists may seem, they are perfectly reasonable considering the hype in the press in the last 10 years or so. Back in 2012, Harvard Business Review declared data science the sexiest profession of the 21st century, only to call it tedious a mere 1.5 years later. Perhaps they were a bit premature in their proclamation. The reality is that data science is less about machine learning models and research and way more about scrubbing and shaping data. Dumpster diving for diamonds in data, if you will. That leads to boredom, and as we have seen, bored people quit, especially highly educated ones. The last few years have seen a massive influx of junior data scientists who complete a few online courses, participate in a Kaggle competition or two with clean datasets, and think that experience represents life as a data scientist in the enterprise. Unfortunately, that is often the mark of what I call rogue data scientists, especially if they refuse to adapt. It's important to note that I'm not talking about researchers in academia or industry who typically work towards publications and not the release of production-grade software. A rogue data scientist is anyone in industry who is paid to deliver results through data and machine learning but has little incentive and interest to operationalize their work. In fact, they mostly work for their own intellectual enrichment. A rogue data scientist therefore ticks several of the boxes shown in either category. The key aspect of technology choices is resume padding, rather than suitability based on requirements. Ideally, each project uses a different framework or novel libraries. Tech is a bucket list and each item needs to be crossed off it. In production use, having more than one deep learning framework makes little sense. The more people use a single framework inside the company, the more experts there are who can help out in case of questions or issues. Most standard frameworks offer more or less the same functionality anyway. That does not mean each initiative must use the same set of libraries and there's no room for exceptions or experimentation. Far from it. There is just little use in using multiple, roughly equivalent technologies to do the same task, unless you're trying to embellish your skills section on LinkedIn. Simple solutions that work, such as heuristics or linear regression, are only done as a last resort when results are demanded or to get rid of an undesirable project. But such options are generally dismissed as being silly. In fact, it's not uncommon to hear rogue data scientists denounce most problems in the industry they are passing through as easily solvable. Yet, all they produce are notebooks that fail to reproduce the results on anyone else's machine or on the full dataset. Still, that's somebody else's problem. They appear unfazed by the fact that the lack of reproducibility makes data science nothing but data alchemy. If they produce a script instead of a notebook, don't be surprised to find a single file with 2,000 lines of code without much structure or documentation. The value simple algorithms generate to the business is irrelevant to a rogue. Complexity of the model is indicative of sheer brain power, and having the largest brain in the room counts. Novelty and innovation trump actual results. This can lead to incessant algorithm tuning to improve performance only marginally. It's rare for rogue data scientists to work on improving data quality or data augmentation techniques to boost the performance. After all, that's data janitorial work. Cherry-picking tasks to work on or lobbying to be put on high-profile initiatives is not uncommon for the rogue data scientist. If they can outsource routine assignments to engineers or offload repetitive jobs onto interns, they will, as long as they remain in control of any credit that is due. GPUs can undoubtedly speed up computations in ML. However, it's rare that everything must run on GPUs. The costs often outweigh any speedups. Still, a rogue data scientist wants a high-end GPU in their laptop. Rogue data scientists tend to be very territorial. Outside interference is seen as an affront. A PhD in STEM is often a good indicator, although by no means a necessary or even sufficient condition. It has been my experience that the academic mindset and excessive focus on research rather than utility often outlive stints in academia. The desire to write any documentation in LaTeX is also a key characteristic. Whether anyone else on the team is competent in its use is of no concern. Instead of writing good documentation or any documentation at all, they prefer to fuss over proper typesetting. Unless you're in research, properly typeset mathematical equations are not essential to development and deployment of machine learning models. A single rogue data scientist in a team of only data scientists is often enough to turn the entire team rogue. An expensive shadow IT is a consequence of a rogue data science organization that picks and mixes whatever it pleases with little regard for the integration into the overall enterprise architecture. Am I being perhaps a bit too harsh? No. I have worked with the rogue kind who sees everything beyond what they consider fun not theirs to do, which means everyone else ends up on the hook whenever results promised by the rogue data scientist don't live up to expectations, and they never do. If you're not in research, having models work in the lab but not in the real world is a clear sign you're nowhere near done. A real data scientist understands that. The reality is that academia, online courses, and data science competitions paint a picture of well-labeled datasets and machine learning as being restricted to mere modeling. That leads to newcomers only wanting to try out every fashionable toy instead of doing the hard work that leads to successful ML-powered products. This is illustrated by the quotations lifted from a recent paper by researchers at Google. Machine learning has long since moved from academia and research to production systems that affect billions of people daily. The same attitudes that worked in academia do not work in the industry, and it's about time we address that. That means rewarding the often invisible but essential work that goes into making machine learning successful. Data collection, data cleansing, documentation, ongoing maintenance, labeling, and so on. And that requires involvement from management. While often ignored, management is crucial as no machine learning product can be handled by a single team that is decoupled from the rest of the business. Solo data science teams that go rogue due to a lack of supervision are a clear indication of the failure of management. Support from executives is important, but only if they understand data and machine learning fundamentally as a core aspect of and an asset to the organization, and they don't just run after the latest fad. Furthermore, management plays a starring role in both data governance and organizational structure. An artificial split between science and engineering is an anti-pattern that leads to many handovers that slow down development and often lead to failures in deployment. I repeat, successful machine learning requires a cross-functional product team where data scientists do not double as managers. Making data ML ready and machine learning successful takes a lot of effort, a lot of team effort. So, what have we seen today, old chum? We have gone through the 6 traps that stand in the way of making machine learning stick and succeed. These are summarized on the right with the Gotham acronym. Data is not unlike underwear, hidden, but it's always a lot dirtier than you think. Data governance is a must. Operationalization cannot be relegated to being an afterthought. If your prototypes never make it to production, you can say goodbye to any returns on your investments. Technology, while essential, cannot solve all problems. Companies often seek full-stack data bat people without success, as they are fictional. Focus instead on training engineers to lean more towards data science and build tools to bridge the gap between science and engineering. In addition, avoid hiring rogue data scientists. Management plays a key role in both establishing data governance and building cross-functional teams with the proper skill sets, technology, and support needed. But if there's only one thing to take away from this talk, it's this. Think in terms of machine learning products, not one-off projects. Production usage must be the ultimate goal, which means operationalization and ongoing maintenance and support cannot be ignored until afterwards. With a product, there is no afterwards. Then work backwards from that goal, a machine learning product running in production, and then include all stages from data through model development all the way to deployment. That way, data as well as the operationalization are clearly visible, and the need for a cross-functional team is obvious too. No Batphone needed. Because remember, Batman is busy. He won't save you. Thanks for listening.
Thanks, Ian, for that interesting presentation. I was really kind of taken with your perspective on a real enterprise approach to machine learning and trying to, I don't know if this is perhaps inaccurate, but to raise the maturity level of how we do machine learning projects within environments. One question I have though is my experience has been that we drill a lot of dry holes in machine learning where we think up front that we have a project that we could do that would result in hidden insight or new knowledge. And even though we have a clean data set, and even though we've gone through and feel like we've got a good result, at the end of the day, it doesn't have that business impact. So we've taken. I just want to. My thought process there is there is does taking every project that you do that's around machine learning and trying to apply these principles to it, does that make sense, or is there some iteration that happens up front, or am I just a rogue data scientist? Is that really what's going on?
There's always a lot of iteration that goes on with machine learning products or projects, however you want to see them. I prefer to see them as products. But what I think the key thing is people tend to think that the machine learning is a core aspect of a final product that runs inside the business, but tweaking that model doesn't necessarily translate into benefit to the business. I have seen way too many products and projects in machine learning fail simply because the data scientists focus too much on eking out the F1 score, the AUC, what have you. And at the end of the day, those did not translate one-to-one to actual KPIs that anyone was tracking. So if you're, for instance, looking at increasing retention and you're a global scale company, think Netflix, Facebook, Spotify, um, getting a teeny tiny change in a model performance metric typically does not have really any impact on your KPIs that you're tracking. So what you really need to do, and this is kind of the operationalization as an afterthought trap, is make sure that that connection from model performance metric to actual business metric, that that connection is not left as an exercise to the reader, essentially, but that you include A/B testing if that's possible or doable in the business, that you actually measure the before and after with the business metrics and not just the model performance metrics. It's very simple to build a model that has great performance, better than a baseline, but it does nothing to the business. Ultimately, it has to have an impact on the business, and that happens through iteration, but it also happens a lot in upfront thinking that, well, the model is a core aspect of this whole business process that it will be embedded in, but it will ultimately not be a separate component. It has impact, and other things have impact on the model, like data quality and stuff like that.
Yeah, it does sound like that governance is really where it's needed as well in terms of just looking at your data model, and but then also thinking about not just an ML. No project is really just an ML project. It's always a business project, right? It's got to come through and solve a business problem. Otherwise, it doesn't make sense to do it. But that governance area, I mean, you touched on it, and I think you spent a reasonable amount of time, but you really talked to it in terms of the data quality and getting good data cleansing going on in your project. Is there other aspects of governance that we need to think about, like, personally identifiable information or the impact of this particular machine learning model or particular product on the environment as a whole? I don't know if that my question is making a lot of sense there.
I think I understand where you're going with it. There are definitely other aspects that are part of that. So with GDPR in Europe, data privacy is a must. It's not just a nice to have. And we as a company value your privacy. Everyone claims that. It has to be something that is baked into the infrastructure. You cannot leave that up to individual product teams, projects to do properly. It's not going to happen. The second aspect of that is that ethics is a major factor. I think part of every ML product should be the question, is this product, when it fails, and it will fail, service is down or the model doesn't give you the right prediction because you're hitting an edge case that you hadn't thought of before, will it affect human lives negatively? In a lot of cases, a Netflix recommendation, if it's wrong, no big deal. If a spam email passes the filter, no big deal again. But if you're thinking about more enterprise use cases, so you're a financial organization, you provide loans to small businesses and people, mortgages, healthcare, of course, now with COVID, a very big topic, but in general, those things and manufacturing as well, where we have high stakes and where security and safety are very important to people, you really have to think about what happens if this model misbehaves, and it will misbehave. It's IT. There's always a case where that happens. So part of the governance should also be ethics, and as I mentioned, and you alluded to, also data privacy and protection. But of course, I talked a lot more about data quality simply because data scientists typically feel that pain the most. The ethical considerations are unfortunately often an afterthought as well. But by and large, they don't affect the pipeline up to where the business still sees it. So, the negative effects happen with interaction with customers, which is still something you have to have on your radar. But when you're doing an ML project, an initiative, building a product, the data quality is what hits you from the get-go. If the data is bad, you have to fix it. That will take a lot of time. If the data looks okay, but you see that when you cross-reference it with other data sets, that there's gaps or numbers don't add up, then you have to basically pivot the project to first fixing those, because there's no point in building a model that predicts whether you will renege on a loan if you're a bank, if the source data that you're basing this on is completely out of whack with reality. So that's why I spend most of my time talking about data quality, because that's what you will mostly be affected by if you work on those products. But I fully agree that security, privacy, ethics should be a core aspect of the whole governance of data as well as machine learning products.
I thought the approach you also took around hiring practices makes a lot of sense if you're, a mature machine learning operation where you've got the business case to support a full team. But as this whole idea of start small and then grow, how do you see that working with your argument that I need a full team in order to be able to really address all of the needs, because there is no one single Batman for my team. Any thought there whenever you're just for those people who are just getting started?
Well, the thing is, it's fine to start small. That's good advice. The only, question you should really have in the back of your mind is what's small. It's not a binary. It's not a Boolean type evaluation. Is this project small because it's one person doing it? Is it small because 5 people are doing it, but the business impact will be limited, etc.? Small is one of those things, you see it a lot. My issue with it often is that it makes people lazy in picking projects. They typically go for what looks easy but might actually be incredibly hard to do. So the very small example that I mentioned with the assembly line, that is actually a case that I worked on when I was in a manufacturing company. Um, it didn't hit us until we actually had the model run. It was live, and then now we need a robot arm to grab faulty parts off an assembly line, and it simply didn't happen because quality control said that's not going to happen. We're not going to do that. That will affect the quality of the glue of the components. No. That was completely not on our radar, but the project started off very small with, here's some data that we have. Can we actually do something with this? Just as a proof of concept that can we use this data to predict something? That's perfectly fine if you start out like that. The problem often becomes that when you then present that to management, the expectation is that, okay, I have this prototype, it runs in a notebook, I've seen the charts. Then going from there to a fully operational product that is maintained, well coded, doesn't have tech debt that needs to be worked down. That is a major step. That is not just the last mile of machine learning. That is basically, you've just finished the first mile. Now come the other, how many you have left. And I think that's kind of the critical change in the mindset that needs to happen in people, that the notebook with the prototype is first mile. It's not the last mile. And if you see that has a potential, then you can still continue being small in the initiative by having an engineer on board. You don't even have to have a product manager from the get-go if it's something that you just want to see how it works in practice. But then thinking the problem through from, here's the prototype, it runs on batch data. This now has to go on a live stream. It has to be integrated. And of course, also thinking about the whole change management that needs to happen. For instance, if this affects people in the business, that a machine learning model is now taking over human decisions that originally were done by humans or by some rules-based system, there has to be a process for those business people to accept the model, to learn that it's a different. The process may be roughly the same, but now someone else is making the decision. It's a computer. They need to get trust in that, and that is often where you see most initiatives think that that's easy, and that's actually very, very hard. And there has been a study or a research, I think, recently by Gartner or McKinsey, I forget, where they actually have that the companies that get exponential returns on ML investments spend about half of their budget on operations and change management, because that is the key, where you see the benefits. I mean, if it runs in a notebook, it looks nice, but it doesn't generate any value to the business. You really need this final component of the machine learning model.
Yeah, that makes all the difference in the world, having the being able to actually take a product that works great in my notebook, but then turning it into a production product. That's the hardest part, right? Like you said, the first mile of the marathon is just getting the notebook working. The last 30 or the actual getting it to a point where I can make business value out of it. We're right at time. Appreciate your time today, Ian. This was really fascinating for me personally. I hope our audience found it fascinating as well. The next session here in the AI and Machine Learning Summit will be Catch Me If You Can, How to Fight Fraud, Waste, and Abuse Using Machine Learning and Machine Teaching with Cupid Chan. Ian, if you've got time, you could spend time in the network session with everyone
Will do.
and give them a chance to ask questions directly of you. That would be great. That next session starts at 12 o'clock. And if you've got an opportunity, everybody who's in the audience, if you have a chance to complete evaluations for the speakers, that would be great. So thanks, everyone. Have a good rest of the convention.